Imagine staring deep into the universe and suddenly realizing it's staring back. That's exactly what scientists felt when the James Webb Space Telescope, the most powerful eye ever launched into space, detected something completely unexpected. This wasn't just another distant galaxy or a beautiful nebula to add to NASA's image gallery. Number was a set of signals, patterns, and anomalies that defied every rule we thought we understood about the cosmos. At first glance, it all seemed random. But the deeper they looked, the more it all began to feel deliberate, structured, and some would even say intelligent. For decades, we believed that the universe was indifferent to our existence, a cold, endless void governed by physics and chance. But what if we've been wrong all along? What if, hidden in the silence of deep space, there are messages waiting to be found? Messages that we were never supposed to see? Today we dive into the latest data from the James Webb Space Telescope. Data so shocking, so unprecedented that some astronomers are beginning to ask the unthinkable. Are we finally witnessing proof that we're not alone? The journey began with an unexpected anomaly close to home. James Webb was pointed toward Neptune, one of the ice giants at the edge of our solar system, a planet so distant and cold that it often seems frozen in both time and space. But Webb saw something that shook decades of scientific understanding. Compared to the data collected by the Voyager 2 flyby in 1989 and recent Earth-based telescopes, Neptune's upper atmosphere had dropped in temperature significantly. Not over millennia or centuries, but within the last few decades. The readings were clear. Parts of the atmosphere had cooled by nearly 10 degrees Celsius without any clear cause. Solar cycles didn't explain it. Internal heat fluctuation didn't either. And here's the unsettling part. Webb also detected unusual shifts in Neptune's magnetosphere. Subtle, but real, like a silent pulse from a heart we never knew was beating. Could an external force be influencing the planet? A passing gravitational anomaly? A shift in dark matter density? Or is something even stranger happening? Something that affects planets silently across unimaginable distances? The data opened the first door, and behind it was more than ice. It was mystery. While the anomaly around Neptune stirred unease, what James Webb found in the TRAPPIST-1 system was enough to make scientists reconsider their entire approach to exoplanetary science. TRAPPIST-1, located just 39 light-years away, is already famous for hosting 7 rocky planets, 3 of which orbit within the system's habitable zone. But Webb didn't just confirm their potential. It revealed something far more profound. Using infrared spectroscopy, Webb identified the unmistakable spectral fingerprints of water vapor in the atmospheres of at least 2 of those planets, TRAPPIST-1d and 1e. And this wasn't just trace amounts. The data suggested dense, humid atmospheres, possibly with cloud systems resembling Earth's. Combined with temperature profiles and orbital resonance patterns, the most likely scenario is this: global oceans, deep, stable, and ancient. Even more astonishing was the detection of ozone-like compounds, molecular markers that on Earth are linked to biological processes. It's not proof of life, but it's as close as we've ever come to finding the right conditions for it. Not once, but twice on 2 planets in the same star system. Imagine it, a miniature solar system with not one but multiple Earth-like worlds circling quietly in the darkness. And now Webb has shown us they are more than theoretical targets. They are real, vibrant, and potentially alive. While the revelations near our cosmic neighborhood were already staggering, James Webb had its eyes on a far more ancient realm. In one of its deepest surveys, it captured light from a galaxy known as JAD SGS 130, one of the oldest ever observed, formed just 330 million years after the Big Bang. But it wasn't just the galaxy's existence that puzzled researchers. It was the Lyman alpha radiation it emitted, a frequency usually absorbed by clouds of neutral hydrogen in the early universe. And yet, this signal was far too strong, far too clear, as if the hydrogen had already been ionized, allowing the light to travel unimpeded. This completely overturns what we thought we knew about the epoch of reionization, the era when the universe transitioned from darkness to light. If this galaxy emitted that radiation at such a time, it suggests something else might have accelerated that process, something massive or intelligent. Was it just natural variation or the footprint of something more deliberate, like the early fingerprints of galactic engineering or some unknown energy process igniting the cosmos before it was ready? The implications are staggering. It's no longer just about what happened. It's about why and who, if anyone, was there to make it happen. As the telescope shifted its gaze to white dwarf systems, stars that have already died, scientists expected only debris, silence, and ruin. But that's not what Webb found. Instead, it discovered planets that refused to die. In the system of WD 1856 plus 534, Webb detected a massive gas planet orbiting just a few million kilometers from the dead star. This shouldn't be possible. The transformation of a sun into a white dwarf usually destroys everything nearby. Yet, here was this planet, not only intact, but apparently in equilibrium. But what stunned researchers the most was what they saw in the planet's upper atmosphere. Webb's instruments picked up traces of vaporized water, sulfur compounds, and other chemical markers that suggested atmospheric regeneration. Somehow, the planet had adapted to survive the death of its host star. This changed everything. The traditional model of life and habitability assumes that once a star dies, so too does any chance for life around it. But what if that's not true? What if there are civilizations or ecosystems built around dying stars, adapted to dwindling light, sustained by alternative energy sources? If some planets can survive death, then maybe some forms of life can too. And suddenly, white dwarfs, once symbols of cosmic endings, might just be the best places to look for intelligent life enduring in the ashes of ancient worlds. While Webb has been uncovering the deep cosmos, it's also been turning its attention to the shadowy corners of our own solar system. One of its recent focal points, the outer moons of Uranus and Neptune, satellites long believed to be dormant, cold rocks with little scientific interest. But what Webb discovered told a very different story. Through infrared mapping, the telescope detected thermal signatures on several small moons that shouldn't have any internal activity at all. Tiny irregular satellites like Hippocamp or Despina displayed heat patterns far above the expected baseline, indicating geological or cryvolcanic activity beneath their icy surfaces. Even more perplexing, Webb spectrometers found hints of complex carbon compounds on their surfaces, possible organic precursors. The question immediately arose: how could such small frozen bodies orbiting so far from the Sun maintain internal energy for billions of years? Some theorize the presence of radioactive decay. Others suggest tidal heating, but neither explains the level of organization in the compounds found, which leads to a third possibility: external seeding. Could something have delivered these compounds? Could these moons be relics of something ancient? Webb sensors then caught something no one expected from a galaxy well known for decades, Messier 82, also called the Cigar Galaxy. Astronomers had already catalogued this galaxy as a starburst zone, intensely active, filled with supernovae and forming stars at an abnormal rate. But now, James Webb found something deeper, an infrared pulse repeating at fixed intervals coming from its central region, not noise, not interference, a beacon. This infrared signal had structure, mathematical spacing, rhythm, and duration consistent with artificial modulation. Though no official conclusions have been drawn, behind the scenes, some scientists have already compared the pattern to early SETI templates used to search for alien transmissions. Is it the result of a highly energetic natural phenomenon like a spinning neutron star? Possibly. But nothing in the visible or X-ray spectrum matches the signature, which raises an unsettling possibility. What if we're seeing the decay trail of something that once transmitted a signal? Not a message to us, but one we were never meant to intercept. Remember Tabis star, also known as KIC 84628552? The strange celestial body whose light fluctuated in unpredictable ways, sparking speculation about alien megastructures. Webb took a closer look. What it found didn't debunk the mystery, it deepened it. Webb's precise photometric data revealed that the dimming events weren't caused by dust, debris, or comets. Instead, thin, opaque objects seemed to pass in front of the star in geometrically consistent intervals. Objects that were flat, angular, possibly massive. The fluctuations suggested structures that might be orbiting in layers or swarms. Natural explanations are still on the table, like unusual planetary ring systems, but nothing so far explains the pattern with complete satisfaction. Webb's thermal sensors also picked up waste heat in the surrounding region, a small, steady infrared glow that doesn't match the star's output, as if something was harvesting energy and radiating the leftovers. The term Dyson swarm is once again being whispered, not as science fiction, but as a legitimate working hypothesis. Lastly, James Webb turned its optics to EL 2744, the Pandora's cluster. This chaotic conglomerate of galaxies has always fascinated astronomers due to its gravitational lensing, allowing us to see galaxies from the earliest universe. But this time, something unexpected appeared in the lens. In one corner of the observation, shadows passed across a background galaxy. Not once, but multiple times during long exposures. These were not instrumental errors. They were actual occultations, meaning something moved in front of the distant light source. But here's the mystery. Nothing visible cast those shadows. Whatever passed through that lens did not emit light, did not reflect it. It was only known through what it blocked. Based on the speed, size, and recurrence, Webb's team believes these objects might be massive yet dark, possibly stealth satellites or more exotically non-reflective megastructures.